Welcome to the virtual seminar on drying and storage system in USA, arranged by Smart Agrotechnology Innovation Youth Network, Bangladesh Agricultural University. I am Sharin Farha, SAIYN National Ambassador. It's my great opportunity and responsibility to welcome you all to the seminar. I am truly humbled by the opportunity to speak to such a distinguished group of scholars and professionals. Well, let me start with a brief introduction of the SAIYN platform. Smart Agro Technology Innovation Hub, in short, SAIYN, is a knowledge-based learning platform for youths where they can explore and boost their interests on smart and innovative agro technologies for sustaining agricultural production, processing, and marketing to ensure food and nutrition security. This is principally a youth-based network focusing on agropreneurship and empowerment. The vision of SAIYN is to be a driving force focusing on to connect teenagers and youths around the globe to be future leaders in smart and innovative agro technologies, engage and empower them to nurture their capabilities and contribute to positive agricultural transformation. In a meaningful way, empowering youth people through capacity building events, creating an entrepreneurial culture among youths, seeking partnerships and collaboration to work. I'm very sorry for the network. Dear participants, now it's time to hear from our keynote speaker, Mr. ASM Younus Sabbir, Graduate Research Assistant, Agricultural and Biosystem Engineering, Iowa State University. He was the former student of Faculty of Agricultural Engineering and Technology, and he completed his Master of Science in Department of Farm Power and Machinery. So now I would like to request Mr. ASM Younus Sabbir to give his valuable speech.
Thank you, Sharin Farha, for introducing me. I'm going to share my presentation. Can you guys see it?
Yeah, we can see
the
it.
presentation.
Yeah, please go ahead.
Hello, everyone. Welcome to this seminar through internet connections. And today we were going to discuss about the modern storage and drying systems in USA. I am ASM Younus Sabbir, as you already know, and I graduated from Bangladesh Agricultural University in 2018 and completed my master's in farm power and machinery in the same university. And also I was in lecturer in the Department of Farm Power and Machinery in Khulna Agricultural University for some time. Currently, I'm studying in Iowa State University and trying to finishing my PhD, and I started from August 2022. So Today we will discuss about the storage systems which are present in USA, especially in commercial scale industries, and also the drying systems of the same industry. And I'll also shed light on my current research activities and try to give you some guidelines on how to process for the higher studies. So if we talk about the modern grain facility, the first thing that comes in mind that how big it is. If you can see the pictures, and you'll see that the if you see the car and compare it with the grain which is lying around in front of it, and the backside the facilities where it has a storage and drying systems, you'll get an idea how much big it can be in USA, the whole grain facility. So the modern grain facilities have much greater storage capacities, and it has also higher equipment capacities. And the yearly throughputs of those grain facilities are really high. If we talk about metric tons, it will be more than 1,000 metric tons or 10,000 metric tons in a year from each facilities. The dust control systems in these facilities are also very important because it moves around a lot, the dust, and it can create explosion. So that's why they have a great dust control system as well. And the automation system on these modern grain facilities are very nice. For example, if you want to guess like how many people needs to run the whole facility, you'll be amazed. You'll need only 3 or 4 people to run the whole facilities just because they are totally automated. And the safety measures of these facilities are also top notch. So before diving into the storage systems of these facilities, I need to share that why we want to store grain. The basic concept of storing grains is to protect the grain from weather, insects, rodents, birds, or mold. And the storage of grain doesn't not only maintain the quality, but it also try to improve the business aspects of the whole industry. For example, storage cannot improve the grain quality, but it holds the quality for a long time so that people can use it for different purposes. And if you don't store the grain for a long time or properly, then it will affect your business. And in the US, for example, I am staying in Iowa. The grain production in Iowa is so high, and the most highest grain in Iowa is corn. And there's so many corn in the harvest season. And if you don't have proper grain storage systems and lots of grain storage system, then the whole storage system or grain facility doesn't work. So repository for local grain supplies are also important. And shipping point to end use destinations via uh, trucks, rail cars, and ships are also another aspect of storing grain. If we talk about the primary components of grain facility, there are mainly 5 primary components of grain facility. First thing is receiving the grain from the farmers or the source, and then distributing the grain into the storage facilities. And after storing the grain for a long time or some time, people need to again deliver the grain to other facilities. For this reason, we need to also do the reclaiming section and the loadout section. And mostly these primary 5 ingredients are present in all the facilities in US and all over the world. If we talk about a grain elevator, at first you need to understand what is a grain elevator. Grain elevator, the word elevator comes from the concept that when a facility receives the grain, it elevates the grain from the ground to up. That's why the name comes elevator. And generally the elevator works as a bucket elevator, screw conveyor, those kind of handling equipments. In the US, people the grain elevators receive the grain from the farmers and process the grains by storing and drying, and then they move it to different facilities like feed mills or ship it to different countries for specific purposes, like for example producing ethanol. They can produce ethanol from corn, which is produced in Iowa a lot. So if we talk about a large grain elevator, and if we compare those systems such as receiving, distribution, storage, reclaim, and loadout, we can see from the picture that this is a grain elevator, and the receiving section of this grain elevator is in here where trucks come. And I don't know if you guys can see or not the mouse of my. Okay, let me just see.
Yeah, we can see your mouse.
Okay, okay. Yeah, so the receiving sections here, the trucks come from in the receiving sections and dump the grain inside of the facility, and then through the distribution channels underneath the ground, and then with the bucket elevator it goes up and distribute into the grain facility, such as in the storage. And after storing the grain, you can also reclaim it through the underground channel or in gravity channel, however the whole system designs. And after reclaiming it, you can also send it through the loadout system, and there's different type of loadout. For example, you can discharge the grain by gravity or mechanical process. So this is a large grain elevator. You can also see the same thing in a small grain elevator, and the same process will be identified in different designs. For example, in this design, we can see that the receiving section is in the back and the storage section is in the front, and the distribution is always in the upper section, and the loadout and reclaiming sections are also present. So if we talk about those specific sections of those whole criteria, we'll talk about the receiving systems at first. The purpose of receiving system is introducing incoming grain into storage facility and transfer grain to distribution system. And grain typically delivered with wagon or trucks in the receiving area. So in currently in what I have seen in those last 9 months, that uh, the wagon or trucks are the most common vehicle to transport grains around here. And we will see that there are a lot of weighing scale and testing probe in the receiving section, so that they can test the sample before entering into the facility and try to judge if those grain are acceptable for their facility or not. And for the design consideration of those receiving systems, we can see that maximizing the throughput of the receiving system and minimizing the weight. That means reducing the time during harvest time, and so that they can they can get more corn during those period where the time is so much busy and so much corn is coming on. There's the main aspect of designing the receiving system. And there are hopper volume which you can the capacity of the hopper volume can be like 1,000 bushel. So I don't know if you guys are familiar with the bushel unit. Bushel is an US unit, which is relevant to the weight, such as kg, ton, those kind of things. And for simplifying the fact is like 40 bushel of corn means 1 metric ton of corn. So here we can say that the hopper volume can be around 30 metric ton, and the capacity of the whole receiving system can be like 500 metric ton per hour. And the receiving system can be used through the receiving of the corn in the places can be used from orifices, gates, pouts, and conveyors. And there's another important aspect of the receiving section, which is valley angle. Valley angle basically is the angle of the hopper, and it needs to be bigger than angle of repose. And angle of repose is another thing. When you place the corn or the grain inside of anywhere, there will be a sloping angle which you can see from those from this yellow picture. This angle is the angle of repose, and the valley angle needs to be higher than this for the delivering whole system, for maintaining the whole system. And if we see the picture after that, the probing section or scale station of the receiving system, that in this picture the trucks comes from this road, and this is the probing station. It takes the sample from the trucks and send it to the facility, and they test the sample and then allow the truck to go enter into the facilities. And the whole operation that I have mentioned, it just happens within 30 seconds to 1 minute. So the sampling of the system and testing of the samples, it needs to be so fast so that they can make a decision properly and reduce the time of the whole operation. And there is another, this area is the scale station in general area. It weighs the truck before entering the facility, and when the truck leaves from the facility, they weigh it again to understand how much corn or how much grain they have put into the facility. It's for recording the inventory and giving the charge to the customer. And this is the gate opening area. You can see this is a truck which is coming into the opening area, and this is the gate. So what happens, usually there is a hopper underneath, it opens up and the corn or the grain dumps underneath through different systems. And after dumping into the corn in the systems, these corns are delivered through mechanical conveyors into the whole distribution channel. And generally receiving systems, what you'll see is maybe in the above ground or underground system. If you see it in above ground, the truck will go, and this upper area, what you can see, there will be the distribution channel. But if it's not above ground, you'll see an underground facility where the truck will dump the corn here, and after the it goes to underground like in a hopper, and then it's distributed through the channels. So if we think about the distribution system right now, the purpose of a distribution system is transport grain to appropriate storage locations. There are a lot of types of distribution channels such as bucket elevators, which transfer the grain vertically, and there are also drag or belt conveyors which transfer the grain horizontally. And the general bucket or belt conveyor is the screw conveyors, or screw conveyors can be also used in different types, like there are twin screw conveyors and different stories of screw conveyors. And there are also distributors and spouting with square or round shapes or lined or unlined shape. And if we think about the design consideration of the distribution system, the equipment of the systems should be much higher than the receiving rate. What it means, like for example, the capacity of the whole facility is, for example, 5 ton per hour. So your design needs to be much higher than 5 ton per hour, because when that harvest in the harvest season, it the flow rate of the whole system can be bigger, and if your equipment is not keeping up with the receiving rate, then it may clogged up. That's why general rules of thumb is to design it much higher than the receiving rate. And the volumetric throughput unit is maybe bushel per hour or ton per hour. In the US, people usually use bushel per hour because it is their usual unit, and people understand it in this way. And the power consumption is also another designing consideration that they use, because in power consumption they want to know the how much power it will consume during the distribution system, and it also depends on the money as well. So that's why they also think about the power consumptions. And if we see some pictures of the distribution system, here we can see that there are belt conveyors which is transferring corn from one storage facility to another. And there are different type of distribution systems which are used in the whole facility, and it depends on how your corn system is placed and how much place you have, how much money you have, and what you are trying to do during this in these facilities. These are the consideration that is made during the distribution systems. And if we talk about the reclaim systems, the purpose of the reclaim system is to remove grain from storage locations and transfer it to shipping system, basically, which is the loadout system. So what happens in reclaim system, I know we have skipped one step, which is the storage. We will talk about it after the reclaiming systems and loadout systems. So in reclaiming system, what happens after storing the corn, you need to remove it, and how you're going to remove it, this is the point where it comes to reclaim. So if we consider of the consideration how to design the reclaiming system, it's almost similar to the distribution systems. Basically, you are removing it from the storage. So in when it was coming into the storage, mostly it comes to the gravity and through the distribution channel, which is in the top section of the facility or the structure. And in the reclaiming system, usually it happens in the bottom section. So there are like different portion design, like a hopper bottom and flat floor. If it's a hopper bottom section, which is like a hopper, then there will be a different techniques like side draw, eccentric discharge, or central discharge. And in flat floor, you will have use bean swipe auger or skid steer loaders. So basically what happens in here, they use different like shovel technique to clean the corn from there and send it to the loadout section. So in here also they use a concept like screw conveyors, bale conveyors to move the corn horizontally or in an inclined way. So if you can see some pictures of the reclaiming system, it's almost similar to the distribution system, but in the bottom section. Here is the bottom section of the bin. It's a concrete silo, and from there you can see it is distributed in the system. And this is also another picture which shows it's distributed to the bottom area. And if we now talk about the loadout systems, the purpose of the loadout system is to transfer grain to shipping containers. And typically, the loadout system is used in the back of the facility. And there is also place in the loadout system where you can run through like road channels. For example, you are moving the corn through semi truck or wagon, then you have to place it in close to the receiving area, because receiving area also uses semi truck or wagon. And usually if your delivery channel is in a bulk way, for example, you are moving corn from USA to Mexico, then you cannot use semi truck or wagon, then you are going to use rail cars. So loadout system needs to be designed close to the rail car or the transportation system so that it reduces the time. So here in loadout systems, you typically use rail cars or sometimes trucks. And if we think about the design consideration of the loadout systems, the equipment sized for speed and the labor efficiency, typically the reclaiming rate needs to be higher, and from the reclaiming rate, the loadout rate should be higher. Uh, and if we talk about how much it can load out at certain time, the general consideration is 210 car units of trains in 15 hours. That means it should load out 110 car unit of trains within 15 hours. And typically equipment used in this area is overhead surge bins with support structure and mechanical fill. So there is a difference in overhead surge bins, which is basically a hopper which is placed on the top of the semi truck so that it can move around and dump the corn in certain way. And there are certain advantage on overhead surge bins, like it can control the loadout and it can move around. But in mechanical field, it cannot be moved around. In mechanical field, you will get automation and flexibility, but you cannot control how much corn you are going to give at certain time. There would be a specific rate which you can change, but you cannot control on one time. And if you think about other equipment such as bulk weigh scale, we also need the bulk weigh scale in loadout systems, because the same reason that we need weighing scale in receiving area, we also need it for the loadout system as well, because the corn will be moving out from the facility. You want to record it for the inventory and for the pricing. And spouting is basically the piping system through which the corn or the grain transfer into the loadout systems. We think about there are two main loadout system, which is one gravity. You can see in the picture that the loadout is happening through the help of gravity. So uh, what is happening here, this is a rail line. The rail will come, the train will come in this way, and it will stop just underneath, and the corn will be transferred through this channel to the train. And if you think about the mechanical way, there are different places, like for example there's a conveyor, or the same thing which is happening in the distribution channel, it will happen in this way uh, to the vehicle that you want to transport it. And there are some other facilities which uses gravity and mechanical system combinedly. So what happens in this kind of facilities is the corn comes up from the top and goes into the system through gravity, and then it's shifted into different channel where you want to put. So these are the basic loadout systems. And if now we want to talk about the basic storage which are happening in the commercial level, then there is one which is concrete tanks, and there is one metal bins, and there's flat storage buildings, and there are also emergency storage options. So now if we talk about the concrete silos that is established throughout the USA, this is the most common commercial grain storage structure. Usually it stores a large quantities of grain, and if you compare the cost with the metal bins or other structure, the cost is relatively low in the long run. And the building life of these concrete silos is around 50 to 100 years. Variety of sizes and configurations in the concrete silos is, the usual heights of these silos is 100 to 150 feet. The diameter is 20 to 100 feet. And you won't find like a standard concrete silo structure. It depends on the needs, requirements, and opinions of clients. So you'll see a lot much bigger concrete silos in somewhere, and after some place you'll see like such a small concrete silo. So it depends on those demands and requirements of those clients. And if we talk about those metal bins, these are very common and getting more popular because they are flexible and is very quick to make. So the advantages of metal bins are that these are convenience to load, unload, and aerate. And you have to think about the aeration as well. Aerating the metal bins is very much helpful and easy. If you, I don't know if you are seeing this picture, there are a lot of holes in the top sections, and these sections helps the bin to aerate. And the price of those metal bins are relatively cheaper, and it is compact and flexible as well. Usual bin life of this metal bin is around 40 years, and but the discharge limit of this bin is limited somehow. If we now talk about those flat storage, uh, these are not very much popular in terms of solely grain storage, because flat storage is also used for other uses such as machine storage or hay storage. So you won't see that much of flat storage around USA right now for the commercial scales. So but storing the grain in flat storage, you need to consider about the moisture content as well. So the grain needs to be dry very properly before storing in flat storage. And during the harvest season, the corn production is so much that the usual or general storage systems like concrete silos or metal silos cannot hold all the corn. That's why it comes into the emergency storage system as well. So emergency storage system is only happening when the storage capacity is exceeded, and usual emergency storage system is basically outdoor piles where you put the corn or other. Basically here in Iowa or in USA they use outdoor piles for corn. So I'm not talking about rice or soybeans or those kind of stuff, because they have a lot of corn. That's why they're thinking in terms of corn. So outdoor piles like this, what you are seeing in the pictures, is very normal during harvest season. And sometimes though the volume of those corn are much higher than the concrete silos or metal silos. um, yeah, the consideration in emergency storage, it can be because it needs to be stored for 1 to 3 months. The stored outdoor piles needs to be designed in that way. And but there are some limitations in outdoor system, because there are higher losses in our emergency storage, and it can be easily accessible for the rodents, insects, rains, or spoilage as well. But one important thing to remember, when you are storing in outdoor, you need your corn needs to be dry. For example, you are receiving corn or grain for 20% moisture content, but you cannot store it in that way. You need to dry it in a certain level, and usually for corn it is around 15%. So you need to remove the moisture content for within 5% before storing in outdoor pile. If we think about the monitoring system of the storage bin, we are very much familiar with temperature of the air and grain in the monitoring system. And we also monitor the relative humidity. But there's another parameter which is used in USA, which is called carbon dioxide. They measure carbon dioxide basically to understand how much carbon dioxide is inside of the silos where the corn or the grain are placed. And from the detection of the carbon dioxide, they can understand if the carbon dioxide is higher, then there are more biological activities happening around inside of the silos, which helps them to detect there's something that you need to do. Because in monitoring system you cannot measure the moisture content continuously, because these storage systems like metal bins or concrete silos are so big, people can't enter into those systems. They enter into this designs facility, so they need to monitor those storage bins from the outside. So measuring the temperature and relative humidity or carbon dioxide is their only way to know if the corn is going bad or not. So that is an important aspect of monitoring the parameter, monitoring the storage bins, that to understand how the carbon dioxide works in the storage inside of the corn. Now, if we talk about the grain drying system, the main purpose of grain drying is to lower the moisture content and maintain the grain quality and prevent microbial deterioration. And the design consideration for grain drying is that there are many terminals where they don't use drying system as individually. So in the grain elevators, usually they have grain dryers to dry the grain and then ship it to feed mill or ethanol plant. So the equipment must be sized to meet receiving rates. For example, the drying is typically a limiting factor in a facility. If the dryer's capacity is 100 bushel per hour or 10,000 bushel per hour, the whole design depends on those drying design. Because if you cannot dry your corn in a timely manner, then if you have higher storage capacity, it doesn't matter, because then you can't dry it and you can store it properly without reducing the moisture content. If you store it, your corn will be damaged. So drying is an important function and a limiting factor to design the whole facility. And usually there are different types of drying equipment. For example, there's a stationary or continuous flow dryer, and there is a tower or stack dryer. We'll be much familiar with the stack dryer, but there are not that much of tower dryer that you are seeing in Bangladesh. So usually in commercial scale, there are cross flow tower dryer, and there are cross flow stackable dryer, and then there are mixed flow dryer. Well, we see a lot of mixed flow dryer in Bangladesh, but not that many of tower dryer, if I am remembering correctly. So if we talk about the tower dryer, how it works, if we see this diagram, there's a heating section, and there's a burner and a blower, and the corn comes through this way and moves in this way, and there's a cooling section as well. The air comes from the bottom, and the blower blows the air, and the burners heated up the air, and this area is basically the main heating section. It passes the air through the sides, and the corn comes in this way and rotates until it is totally dried. So this is a typical picture of a tower dryer, and you can see some cross section as well. Here you can see this is the hot area, this is the burner, this is the coolant area, and this is the corn which is surrounded by the hot area. So here is a video that I have that I have used from the YouTube. It will give you a better idea how the tower dryer works. I'm gonna play the video. If you cannot listen it, please let me know.
There is no sound actually.
Okay. Can you hear it right now, sir?
We cannot hear, but we can see. That's the
Okay,
player is
okay.
on.
Then let me say what is happening here.
Yeah, that's better.
So basically the corn is coming from this way, and it is moving in the sides, and this is the main chamber, and you can see that this chamber has different sections, and each section has different functions. And when the corn is filled throughout the system, the burner will light up and the air will be heated, and from this hot air it will pass throughout the channel, and that's how the whole drying system works in the tower dryer. And if you see that these are close to circulate the air properly, and there is the cold air which is coming from the ambient, and it will show some other factor like it will recirculate the corn until it has the optimum moisture content, and after the whole drying section, it will pass through these channels and go into the facilities in other maybe storage bin on other section. So basically this is the principle of tower dryer. And if we think about next dryer, which is called cross flow stack dryer, so this dryer has the same principle, but that tower dryer was vertically structured, and this is a horizontally structured dryer. In here the principle is almost similar, like there's a hollow section where the hot air will be heated, and the corn will be in the surrounding area, and the fan will blow the air through the system, and it will crossly interact with the corn. So but this is the reason it says stackable cross flow dryer, because this is one singular unit. You can add more unit to dry more corns, so it can increase the capacity based on your demand. So that's why it is a stackable cross flow dryer. There's another section, another thing which is called mixed flow dryer, and there's another video for it. I think if you see it, let me explain the video. So this is a cross flow this is a mixed flow dryer, and which is very common in our country as well. This dryer is also stackable. You can stack it and increase the capacity. So the filling of the corn is from the top section, and the corn filled throughout the whole channel. And you can see there are different patches where you can put the corn, and there's also a hollow system like the cross flow dryer to pass the hot air inside of these dryers, and the hot air passes through these systems. And there's another area to cool the to cool as well. This is the coolant section in underneath. So usually what happens in mixed flow dryer is there's 1/3 of cooling sections and 2/3 of hot uh, uh, 2/3 of heating sections. So for example, if the capacity needs to be increased, then the cooling section can be removed, and the whole 100% of the dryer can be used for only heating. So that's why mixed flow dryer is getting popular in US, so that they can increase the capacity based on their demand. And you can see the mixed flow here. One flow is coming straight and one flow is coming from the sides. So the flow's direction is mixed. That's why it names mixed flow dryer. I think we can continue from the mixed flow dryer. So there's another drying system in the commercial scale, which is called Inban Drying. What we have seen in other dryer is there's a other separation, other specific unit for drying. But in Inban drying system, you don't have a separate drying system. The drying system is attached with the silos, the silos that we have seen before, which is metal silos. In metal silos, if you can put a burning unit and a fan and certain design consideration for drying, you can use those storage bin for the drying system as well. This is called in-bin drying. So the definition of in-bin drying is in-bin drying methods are those in which grain is dried and then stored in the same container. So if we see the picture, you will get a better idea that in-bin drying in in-bin drying, there will be a perforated floor underneath, and the fan will heat up the blower or burner will heat up the air, and it will the fan will pass the air inside of those underneath, which is called plenum. And in this plenum, there is a perforated floor which will pass the air into the whole system, and in this way the corn will continue to dry. So generally, the dryer in the in-bin system is equipped with perforated floor, an electric motor-driven fan, an air heater or burner. Sometimes they doesn't have an air heater or burner, and it just depends on the temperature or the weather condition of the ambient. So the main limitation with in-bin drying is the weather condition. If the weather condition is so much cold, then you cannot just dry it because you will need too much energy. So it depends on the weather condition and what time of the year you are drying in the in-bin drying system. There is another drying which is called combination drying, where you can use the conventional dryers for drying the corn in a high capacity, and then move it to a cooling bin to cool down and do the rest of the drying. In this way, what happens is you are utilizing the whole system in a better way. The energy costs are reduced compared to high speed drying. For example, you are drying the corn here till it's like 20% or 18% moisture content. Then you can transfer it to the cooling bin and dry the rest of the corn, and up to like 15% you can do the rest of the drying in the cooling bin. So that's how you can reduce the energy cost and increase the efficiency of the whole system. And you can also increase the drying capacity and improve the grain quality as well through combination drying. So basically these were my whole uh, information that I have talked about, and these things were gathered from a course that I have taken in Iowa State University, which is called ABE 469 or 569. So basically 469 and 569 is a graduate and undergraduate level course simultaneously, and the videos that I've shown you, these were collected from YouTube. So right now I'm going to talk about my current research activities. Currently I'm working in a project titled Assessment and Approaches for Achieving Net Zero Carbon Emissions for Grain Drying, Handling and Storage Operations. So basically what we are trying to achieve is how to reduce the carbon emission, and if we can like achieve net zero carbon emission in drying system, handling and storage system, the whole agricultural operations is much more greener. And main point of view right now for us is to use renewable energy or energy which can produce a high amount of energy in a short time and can be used in those high facilities or big facilities. So if we increase the efficiency of a dryer, it automatically give better or sorry, it automatically give less carbon emission for the environment. So if we have better drying system or storage system or handling system, it will have much more greener environment throughout the whole world. So that is our main research objective right now, to find out which technologies can we use other than the conventional drying or storage systems in those grain facilities. Right now, my primary research station is Feed Mill and Grain Science Complex in Iowa State University. So Iowa State University has a feed mill which is building right now, and we are hopefully to operate within the fall semester, which is August of 2023. And my supervisor in here, Dr. Meyer, he is the director of this feed mill and science complex. And currently, my responsibility in the feed mill is to manage grain storage, drying, and handling operations. So when in August, I need to work on those things and control the whole grain storage, drying, and handling operations. If you see the picture right now, this is a current picture, and this is the feed mill, and you can see there are grain silos, the metal bins that we have talked about. There is other two bins which is called wet holding bins. So this is an interesting concept as well. Like when the corn is coming in the facility, they don't put the corn directly in the bins because these are wet. So then they what they do, they before putting it there, they will put in the wet holding bin and they will dry it. And you are not seeing the dryer here. We have a mixed flow dryer which you will see in the next picture. So this picture was taken before that dryer was placed. So right now there is a dryer in here. So in the wet holding bin, there's the wet corn, and it will be transferred to the dryer and then dried and then transferred into the metal bins. And so this is basically the grain storage and drying system. So this is another thing which is called the feed mill, and and in here you do the pelleting, grinding, hammering, conditioning of the grain and corn and other stuff to make feeds for different animals. So this is as a whole the typical picture of a feed mill in the USA. So here's the picture that I was talking about, the mixed flow dryer that we have right now. We have it, and from the wet holding bin you will get the corn to the mixed flow dryer, and then after drying it you can transfer it to the general metal bins. So basically this is my current research activities. Now if I want to talk about some higher studies, I would like to talk about higher studies later. If you guys have any questions about those about my presentation or anything, feel free to ask questions. Thank you.
Thank you, Engineer Sabbir Bhai, for your valuable speech. We have seen various different views about drying and storage system and sustainable development from his speech. Think great, do great, innovate for green planet. SAIYN is moving ahead with this slogan. Besides, SAIYN has a very strong organizing structure for moving forward in a very much systematic way. We have 7 more universities along with Bangladesh Agricultural University with this journey. So we hope it will be easier to bring the fruitful conclusion together. Now it is the time for question and answering session. I would like to request the participants unmute yourself and ask your question if you have any, either related to today's presentation or about higher studies in USA. You can also use chat box if you have any questions to our speakers or provide comments in this discussion session.
Hmm.
Maybe I can ask small questions to Sabbir. Thank you, Sabbir, for giving overview of grain drying and storage system in USA. So we can see the systems are quite big than what we used to see here in Bangladesh. So it was really nice presentation and nice overview. So hopefully our students have got some ideas what things are happening in developed countries, especially in USA. So my question is that you showed us 3 different types of dryer, like tower dryer, cross flow dryer, mixed flow dryer. So question is, how much, like actually, what is the set point of the temperature for drying the grain in those dryers? And another question is that you talked about the net zero carbon emission. It's very interesting that you want to make net zero carbon emission in drying and storage system. So actually, you talk a little bit on net zero carbon emission, but what is the idea behind and how you are going to make it net zero? Because this is a crucial issue for all of us. So thank you very much.
Thank you, sir, for this question. These are very important questions. I wanted to add slides which should have the temperature set points for those dryers, but unfortunately somehow I missed it. So the usual temperature in here, they use the Fahrenheit system, so I'm gonna use the Fahrenheit systems. So the usual set point for the temperature is 180 degree Fahrenheit to 220 degree Fahrenheit. It depends on the initial moisture content of the corn which received by the facility, and if the moisture content is higher, then they're giving a temperature which is around 220 or 210 degree Fahrenheit. And if they're receiving less moisture content, then they're giving it like 180 degree Fahrenheit. The usual moisture content that they're receiving in the facilities is around 20 to 22% moisture content of corn, and they try to reduce the moisture content in 15% of moisture content. So one interesting thing in grain elevator in USA is they're getting the corn in terms of the moisture content. For example, if a farmer brings like their set point is 15.5 or 15% moisture content for the grain elevators, and the farmer brought like 16% or 17% moisture contents of corn, then that farmer will not get the money that he is supposed to get, because the grain elevator will charge the farmer for reducing 2% moisture content. So that is one aspect of the drying system. I hope this answered your question. And about the net zero carbon emission, this is a challenging concept, as you know. So we are starting to brainstorming how we can achieve the net zero carbon emission right now. For example, we explored option like heat pump. So heat pump is basically the opposite of AC. In AC, you are drying, you are giving cold to the air to the system, and in heat pump you are giving hot air to the system. So what happens if we think about those 4 steps of AC, which is like evaporation, compression, expansion, and other thing. So it have a condensation. So what happens during we need the hot air, and we try to receive the hot air from the condensation, and through the heat pump we can heat the air. So in heat pump, the efficiency is much higher than general drying system, and we have found that the hot air temperature from the heat pump can be somewhat similar to the general or conventional dryers, but the cost of heat pump is much higher than those dryers. And so that's one aspect of the heat pump. But it's not that we're gonna implement heat pump. We are thinking as well, we are also thinking about renewable energy like solar panels. If we can put up big solar panel system for the grain industry, that is also helpful. So it's not we are fixing the idea right now, we're exploring, brainstorming, and throughout the drying modeling system and cost analysis and efficiency performance, hopefully we'll get an answer. I hope this answers your question, sir.
No, thank you, Sabbir. This is Monjurul Alam. Can you just
Yes, sir.
stop sharing, please, so that everyone can see the faces? Yeah.
Thank
Yeah.
you.
It is not really the questions, that it is really, thank you, Younus. You have actually given a very nice presentation, especially the students who are actually having the course here, agricultural process engineering, and some of the students have done work on, like you, that's on storage and drying systems. So we have also designed, the mixed flow, the drying systems of a 12 to 16 ton capacity dryer. So that is the same system. Here the temperature is actually maintaining 62, around 85 degrees Celsius. So what I will mention that it is similar to that. So
Yes, sir.
that's good. And
Yeah.
especially another thing, that your concept of heat pump is really good. I know the initial investment cost will be much higher, but if it works, then that will be a good thing to do. So in the case of heat pump, there will be some energies needed, whether that energy will be coming from the renewable source or some other source that need to be considered. That is one of the areas. And another area, the students who are actually now participating in this particular seminar, they are really keen that, especially in the larger storage system. So Bangladesh government has already installing some of the larger grain system, although these are not still in operation, but when it will be in operation, we like to see, even the student like to see those, actually the silos, how these things are actually operating. Especially there is a very important thing, whether if there is a moisture content by some means is the greater, then there is a chance of formation of mold actually, and microbial activities, especially the mycotoxin that will develop. So carbon dioxide concentration, that indicates the insect or pest, isn't it? And even the grain respiration, through this the carbon dioxide concentration will come. So in that case, do they use some of this, how do they actually control some of the insects or pests if there is any, in case of the carbon dioxide increase within the system? And are they using some of the sensors that is from the outside, either the relative humidity or the temperature, again, the carbon dioxide? Do they use some of the sensors and some of the instruments to measure the carbon dioxide? So these are my observation. It is really good that today's participant will have some knowledge of the big storage system, how it is operating. And especially it is interesting that you are going to do some work that is generate carbon emission. That is really good idea. But we will be looking forward to see your success in your particular experiment and studies. And that will be a good thing for us to actually carry on in the future. So thank you again for your good, nice presentation and ideas, and you are working. Thank you.
Thank you, sir, for your insights on the heat pump and net zero carbon emission. The two questions that you had, one about how they mitigate if the corn is getting bad or if the carbon dioxide is higher. Well, in that aspect, I haven't explored those things yet, but if I will in future, I will definitely like to give you an answer. But what I understand from their perspective, they do not want to give them certain situations where they will have like ores corn, so they're trying to monitor those system constantly. They have automation system aligned with those monitoring systems. You have asked about those sensors. Yes, they have sensors for temperature, for measuring temperature, relative humidity, and carbon dioxide. What usually they do, they have the general practice that I have seen for the carbon dioxide sensors, they put a carbon dioxide sensors in the bottom or the plenum section of the storage bins, and another one in the top sections of the storage bins. In that way, they have a better idea how much carbon dioxide is releasing from those bins. In that way, they know the level of carbon dioxide. And for the temperature and relative humidity, they have right now a system where they put cables inside of the metal silos. I don't know. Let me. I have some pictures, but I haven't added it into the thing. Maybe I would, if I could add that, that would be helpful. So they're like a long rope of sensors. There are sensors after 1 meter or 3 feet or 5 feet, and like in each cable there are like 10 or 15 sensors from the top to bottom of the grain bin, and these type of cables are around the whole grain bins. For example, there may be 7 or 8 cables inside of one grain bins, and each cable may have 10 to 15 temperature sensors to sense the temperature inside of those bins. In that way, they knows the temperature of each sections from the inner section to outer section and from the top to bottom. That's how they are measuring the temperatures and the relative humidity. And for the carbon dioxide, they are putting it on the top and the bottom of the grain bins. I hope this answers your questions.
Oh, thank you. Thank you for your answer.
I have a question. I have
I have-
raised my hand. Can I
Dr.
ask?
Mohammad Ayub Hussain, sir, please ask your question.
Thank you, Mr. Younus for your excellent presentation on grain storage and drying in USA. So I have a little question. As our honorable or respected Monjurul Alam sir raised the question, there are a lot of sensors to monitor the system. But I have a question. If the moisture content of the product increase from 14 to 15%, 1% or 14 to 14.5%, how the temperature is reduced? Is there any system of the storage? How the temperature is stored, and also the carbon dioxide? If the carbon dioxide increased or decreased, how they control this temperature, the moisture content and carbon dioxide in the storage system. Another thing as mentioned, Dr. Chayan Kumer and also Monjurul Alam sir, the heat pump drying is a good concept. And one of some part of my postdoctoral was the heat pump drying of medicinal plant. Heat pump itself reduced the energy cost about 30% of the electric drying system. But this system is very costly in terms of money. And heat pump drying is low temperature and low humidity. It is very difficult to raise the temperature higher. And heat pump is generally used for medicinal plant and some herbs or not for use for grain in the world. Anywhere in the world, heat pump is used for the drying of grain, but you are trying to use heat pump drying for grain drying. What is your comment, and have you any literature on heat pump drying of grain? This is my observation. Thank you very much. And another thing, your zero emission is very too difficult to reduce zero emission. In heat pump drying, you have to use energy, huge energy. That is, you have to electric energy or gas or something like that. You have to use. Heat pump drying is a system to reduce only the relative humidity. So what is your comment, please? Thank you very much.
Thank you for your questions. For the first question that you had, to if the moisture content is increased, how they try to control it. What I have seen there in the metal beans or the silo beans, they have fans, and I have also shown the the bin drying systems. So usually by default in those drying in those metal silos, they have fans and they have aeration systems to aerate the whole silo. So if, for example, if the temperature needs to be getting higher for reducing the moisture content, they try to speed up the fan and try to add the burner as well to raise the temperature so that the moisture content can be reduced to the optimum level again. So that's one of the answers for your questions. And for heat pump, we also know that there's a lot of challenge for heat pumps. We are not saying we're going to implement heat pump right now. We are trying to brainstorm the ideas how we can what we can use for the grain drying. And yes, we have found some literatures for heat pump in grain drying system, which are found in 1970s or 1980s in the USA and Canada. They had extensive research on heat pump dryers in those times, but what they have concluded that the cost of the heat pump is too much high, but we can use heat pump for grain drying. There are literatures which we can support for this. I hope this answers your questions.
Thank you. Actually, heat pump drying is not economically feasible for grain drying. Technically, it is okay. For a small
Yes.
amount of drying, this is technically okay, but may not be economical feasible.
Yeah,
Thank
yeah. We are also exploring and aware of this thing. We are just trying to brainstorm right now what other options we have, like electric resistance heater, heat pump, solar dryer, other technologies to achieve less carbon emission. That's our main objective.
Okay.
Thank you.
Thank you everyone for joining this seminar and investing your valuable time. We hope it's the starting of a new journey, and we will.
Purno,
Yes, sir.
before closing, I think I would actually ask the Sabbir if you just give quick brief on the higher studies about in USA.
Yes, sir. I was planning to do that right now.
Just in quick, so yeah.
Yeah, I'm gonna share the slide again.
আসসালামু আলাইকুম, আমি জান্নাতুল নাইম।
ওয়ালাইকুম
আমি
আসসালাম।
হায়ার স্টাডিজ বিষয়ে একটা প্রশ্ন করতে চাচ্ছিলাম।
হ্যাঁ,
আমি এখন মাস্টার্সে পড়ছি ফার্ম পাওয়ার অ্যান্ড মেশিনারি ডিপার্টমেন্টে। আমি গ্রিন এনার্জি নলেজ হাব ল্যাবরেটরিতে কাজ করছি বায়োগ্যাসের উপরে। রিহাইকের প্রজেক্টে এমএস ফেলো হিসেবে আছি। তো আমার যে কোশ্চেনটা, যে সেন্ট্রাল অ্যাপ্লিকেশন অথবা প্রফেসর ম্যানেজিং এর মাধ্যমে ইউএসএ যে অ্যাপ্লিকেশন, কোনটাতে স্কলারশিপ পাওয়ার পসিবিলিটিটা বেশি থাকে?
এটা আসলে ডিপেন্ড করে। যেমন মানে সেন্ট্রালি অ্যাপ্লিকেশন মিন্স হচ্ছে সবকিছুই হচ্ছে ইভালুয়েট করা হবে। ফর এক্সাম্পল আপনার রেজাল্ট, আপনি কিভাবে অ্যাপ্লাই করছেন, ওইখানে অনেকগুলো স্টেপ আছে, স্টেটমেন্ট অফ পারপাস, হয়তো আপনি ইংলিশ প্রফিসিয়েন্সি, ল্যাঙ্গুয়েজ লাইক আইলস দিয়েছেন, ওইটার স্কোর কেমন। তো সেন্ট্রাল অ্যাপ্লিকেশনে দেখা যায় এই সবগুলা সাথে হচ্ছে হলো আপনাকে মানে কম্পিট করতে হয় প্রত্যেকটা পার্টিসিপেন্ট। কিন্তু যখন আপনি প্রফেসরের মাধ্যমে অ্যাপ্রোচ করবেন তখন জিনিসটা আরেকটু সহজ হয়ে যায়। যদি প্রফেসর আপনার সাথে কাজ করতে ইন্টারেস্টেড ফিল হয়, আপনার রিসার্চ এরিয়ার সাথে তার রিসার্চ এরিয়া অ্যালাইন হয়, তখন দেখা যায় যে বাকি যেই জিনিসগুলো যেমন ইংলিশ প্রফিসিয়েন্সি, ফর এক্সাম্পল আইএলটিএস অথবা জিআরই, ওই জিনিসগুলোর রিকোয়ারমেন্ট একেবারে থাকে না এরকম না, বাট আইএলটিএস এর একটা মিনিমাম রিকোয়ারমেন্ট ইউনিভার্সিটির থাকে। ফর এক্সাম্পল যেমন আমার ইউনিভার্সিটির মিনিমাম রিকোয়ারমেন্ট হচ্ছে 6.5। তো তখন দেখা যাবে যে আপনি 6.5 যদি আইএলটিএস এ পান তখনই মানে এটা ইজি হয়ে যাবে। সেটা হচ্ছে আমি প্রফেসরের থ্রুর কথা বলতেছি। সো কম্পারেটিভলি যদি বলা হয় তাহলে প্রফেসরের অ্যাপ্রোচটা মানে লিটল বিট ইজি সেন্ট্রাল অ্যাপ্লিকেশন থেকে।
থ্যাংক ইউ ভাইয়া।
আমি জাস্ট স্লাইডটা শেয়ার করে একটা বেসিক আইডিয়া দিই যে আসলে হায়ার স্টাডিজে মানে কি হতে পারে, মানে বা কি কি স্টেপ আছে, এটা হয়তো আরো ইজি হবে সবার জন্য। উম, দেখা যাচ্ছে স্লাইডটা। তো বেসিক্যালি প্রথমে হায়ার স্টাডিজ এর কথা বলতে গেলেই যেটা আসে সেটা হচ্ছে হলো, যেহেতু হায়ার স্টাডিজ মিন্স হচ্ছে হয় মাস্টার্স করতে হবে, মাস্টার্স এর জন্য অথবা
Put in
পিএইচডির
the
জন্য আমরা
slideshow
আসতেছি।
mode.
তো ওকে, এই সেশন এই এতটুকু স্যার আমি বাংলাতেই বলতে চাচ্ছি, যেহেতু বেসিক্যালি এটা ওদের জন্যই, যাতে
Okay,
ওদের
very
বুঝতে
good.
সুবিধা হয়।
Yeah.
তো প্রথমে যে জিনিসটা আসে সেটা হচ্ছে মানে রিসার্চ এক্সপিরিয়েন্স। কারণ হচ্ছে হলো আমরা যখন মাস্টার্স এ বা পিএইচডির জন্য আসবো, অবশ্যই আমাকে কোনো না কোনো ধরনের রিসার্চের সাথে ইনভলভ হতে হবে। তো যখন হায়ার স্টাডিজে আসা হয় তখন রিসার্চ এক্সপোজার থাকলে একটা স্টুডেন্টকে ইভালুয়েট করতে সহজ হয়। তো প্রথম হায়ার স্টাডিজ এর স্টেপই আমি বলবো সেটা হচ্ছে রিসার্চ এক্সপোজার থাকতে হবে। তারপরে একটা এভারেজ সিজিপিএ থাকতে হবে। অনেক সময় মানে অনেকে দেখা যায় যে যদি একটু কম সিজিপিএ থাকে তারা হয়তো ভাবতে পারে যে আমার পক্ষে কি হায়ার স্টাডিজ করা সম্ভব হবে কিনা। ব্যাপারটা এমন না, মানে একটা জিনিস আরেকটা জিনিসকে হয়তো মানে একেবারেই ভালো রেজাল্ট লাগবে না তাও না, বাট মানে একেবারে যাদের জন্য কম সিজিপিএ বা একটা এভারেজ সিজিপিএ আছে তারাও হায়ার স্টাডিজ ডেফিনেটলি পার্সু করতে পারে। তখন হয়তো তার একটু বেটার রিসার্চ এক্সপিরিয়েন্স লাগবে। হয়তো আরেকজনের একটা বা দুইটা সায়েন্টিফিক জার্নালে হয়ে যাচ্ছে, সায়েন্টিফিক পেপারের কারণে হায়ার স্টাডিজ হয়ে যাচ্ছে, কারোর জন্য হয়তো এটা তিনটা চারটা লাগবে, বা স্পেসিফিক একটা রিসার্চ ফিল্ডে হয়তো একটু বেটার রিসার্চ লাগবে। সো মানে সিজিপিএ কম হলে যে হায়ার স্টাডিজ করা যাবে না ব্যাপারটা এরকম না। আহ, এটা একটা জিনিস। আর অবশ্যই হায়ার স্টাডিজ এর জন্য আমাদের নেক্সট যে স্টেপটা সেটা হচ্ছে হলো আইএলটিএস অথবা টোফেল সাধারণত লাগে। তো এই দুইটার মানে একটা আমার থাকতে হবে, এবং মানে এটা দেশ ওয়াইজ মানে ভ্যারিও করে। দেখা যায় যে কোনো দেশে হয়তো আইএলটিএস টোফেল এর কোনো একটা প্রিফার করতেছে। তো খুব নর্মালি যেটা হয় যে আইএলটিএসটাই সব জায়গাতে একসেপ্টেবল হয়। এখন আবার কিছু কিছু জায়গায় ডুওলিঙ্গো একসেপ্টেড হচ্ছে। তো ওইটা ইউনিভার্সিটি, দেশ সবকিছু মানে দেখে দেন ডিসাইড করাটা ভালো যে আপনি কোনটা দিতে চান। দেন আরেকটা যেটা সেটা হচ্ছে জিআরই। জিআরই এখন অনেক জায়গায় অপশনাল হয়ে গেছে, অথবা স্পেসিফিক ডিপার্টমেন্টে জিআরই লাগতেছে, বাকিগুলাই হয়তো লাগতেছে না। সো বাট জিআরই অনেক জায়গায় লাগতে পারে, এবং জিআরই থাকাটা অ্যাডভান্টেজিয়াস যখন ওই যে যে দুইটা মানে যে দুইটা অ্যাপ্লিকেশন প্রসেস বলা হলো, প্রফেসর আর সেন্ট্রাল। তো প্রফেসরের থ্রুতে গেলে যদি ইউনিভার্সিটির জিআরই রিকোয়ারমেন্ট না লাগে, তা মিনিমাম রিকোয়ারমেন্ট না লাগে, তখন দেখা যায় অনেক সময় জিআরই ওয়েব করা হয়। বাট যদি সেন্ট্রাল অ্যাপ্লিকেশনে যাওয়া হয় বেশিরভাগ টাইমে জিআরইটা মানে লাগে, কারণ জিআরই আছে মানে একটা এক্সট্রা অ্যাচিভমেন্ট আছে, সেই ক্ষেত্রে তার প্রোফাইলটা আরো বেটার হবে। তো এটা হচ্ছে জিআরই কনসেপ্টটা। তারপরে আমরা আরেকটা জিনিস ওভারলুক করে যায়, এই সবগুলোর পরে আরেকটা ইম্পর্টেন্ট জিনিস হচ্ছিল স্টেটমেন্ট অফ পারপাস। সো স্টেটমেন্ট অফ পারপাস জিনিসটা এরকম যে মানে আপনি যে হায়ার স্টাডিজে আসতেছেন, একটা স্পেসিফিক ডিপার্টমেন্টে পড়তে যাচ্ছেন, একটা স্পেসিফিক ইউনিভার্সিটিতে পড়তে যাচ্ছেন, আপনি একটা জায়গায় রিসার্চ করতে যাচ্ছেন স্পেসিফিক ফিল্ডে, এই জিনিসগুলো কেন করতে যাচ্ছেন, আপনাকে কি মোটিভেট করে, মানে এই সবকিছুই হচ্ছে হলো স্টেটমেন্ট অফ পারপাসের মধ্যে লেখা থাকে। এবং এটা টোটালি একটা মানে ইন্ডিভিজুয়াল বা পার্সোনাল লেটার। সো মানে বা বলা যেতে পারে যে একটা পার্সোনাল ফর্মাল লেটার, যেটার কারণে মানে অ্যাজ এ হিউম্যান বিং, অ্যাজ এ স্টুডেন্ট, অ্যাজ এ রিসার্চার মানে আপনি কেমন, সেটা হচ্ছে হলো স্টেটমেন্ট অফ পারপাসটা আর কি, মানে যারা ইভালুয়েট করে তাদেরকে হেল্প করে বুঝতে। তো স্টেটমেন্ট অফ পারপাসটা অনেক ভালোভাবে পলিশড ওয়েতে লেখাটা আর কি জরুরি। এটা হচ্ছে হলো একটা। আর বাকিটা হচ্ছে লেটার অফ রিকমেন্ডেশন। লেটার লেটার অফ রিকমেন্ডেশন অবশ্যই যারা আপনাকে ভালো করে জানে, আহ, যেই যেই টিচার আপনাকে ভালো করে জানে তাদের কাছ থেকে নেওয়াটা ভালো। তাহলে তারা একটা অনেস্ট ফিডব্যাক দিতে পারে, যেটার মাধ্যমে আর কি আপনার প্রোফাইলটা আরো এনরিচ হয়। সো এই কয়েকটা জিনিস হচ্ছে হলো হায়ার স্টাডিজ এর জন্য ইম্পর্টেন্ট। অবশ্যই রিসার্চ এক্সপোজার দরকার আছে, সিজিপিএ এভারেজ অথবা বেটার হলে আরো ভালো, আইএলটিএস দরকার আছে, জিআরইটা অপশনাল, স্টেটমেন্ট অফ পারপাস খুবই ইম্পর্টেন্ট, লেটার অফ রিকমেন্ডেশনও দরকার আছে। এগুলা বেসিক্যালি আমার মতে হায়ার স্টাডিজ এর স্টেপস। আর মানে হায়ার স্টাডিজ এর মানে শুনতে মানে কি বলে যে খুবই ভালো যে হায়ার স্টাডিজ, বিদেশে পড়াশোনা বা এই জিনিসগুলো, বাট আরো একটা জিনিস আমরা ওভারলুক করে যাই হায়ার স্টাডিজে, সেটা হচ্ছে হলো যে আদৌ হায়ার স্টাডিজটা আমার জন্য কিনা। মানে আপনি যদি জেনুইনলি রিসার্চের প্রতি প্যাশনেট না হন, তাহলে হায়ার স্টাডিজে, মাস্টার্সে অথবা পিএইচডি তে এসে সার্ভাইভ করাটা অনেক সময় ডিফিকাল্ট হয়ে যায়। কারণ আপনি যদি সেলফ মোটিভেটেড না থাকেন ওই রিসার্চের প্রতি, তাহলে এটা খুবই ডিফিকাল্ট মানে এই জার্নিটা যাওয়া। আর অবশ্যই অনেক ধৈর্য থাকতে হয় হায়ার স্টাডিজে। কারণ হচ্ছে হলো মানে এই যে যেমন হিট পাম্পের কথাই বলতেছি, জানি না হবে কিনা, কিভাবে হবে, সো বাট মানে অপশন এক্সপ্লোর করতে হবে, ওই পেশেন্সটা থাকতে হবে। এবং মানে কি বলে যে একটা ডেডলাইন, একটা কিছু ফিনিশ করার ডিটারমিনেশনটাও হায়ার স্টাডিজে দরকার। আর একটা জিনিস অবশ্যই অনেস্টি দরকার। অনেস্টি না থাকলে দেখা যায় যে কাজের কোয়ালিটি মানে ভালো হবে না। এবং এইসব দেশে মানে কাজ অনেস্ট ওয়েতে না করলে এটা মানে ধরা পড়ে যায় খুব সহজেই। কারণ এখানে মানে সবাই সবার কাজ পড়তেছে, সবাই কে কি করতেছে এই নলেজ গুলো পড়তেছে, জার্নালে কে পাবলিশ করতেছে, কি ধরনের কাজ হচ্ছে, এই সবকিছুই কিন্তু তাদের একজনের ফিল্ডের সাথে সবাই আর কি রিলেটেড। সো এই জিনিসগুলো আর কি হায়ার স্টাডিজ এ ইম্পর্টেন্ট আমার মতে। এটাই ছিল আর কি হায়ার স্টাডিজ এর ব্যাপারে। আপনাদের কোশ্চেন থাকলে বলতে পারেন প্লিজ।
জি, আমার একটা কোশ্চেন আছে। আমি মাহফুজুর মান্নান উদয়, ফ্রম ডিপার্টমেন্ট অফ ফার্ম পাওয়ার অ্যান্ড মেশিনারি, বাংলাদেশ এগ্রিকালচারাল ইউনিভার্সিটি। তো আমরা এখানে হচ্ছে দুই ধরনের সাইলো দেখলাম, একটা হচ্ছে কংক্রিট সাইলো, একটা হচ্ছে মেটাল সাইলো। তো আমরা জানি এদের হচ্ছে হিট অ্যাবজর্পশন পটেনশিয়াল হচ্ছে আলাদা। তো মেটাল যে পরিমাণ হিট মানে কনভেকশন পদ্ধতিতে যে পরিমাণ হিট অ্যাবজর্ব করবে, হচ্ছে কংক্রিটটা সেই সেই হিসাবে করবে না। তো
হুম।
হচ্ছে এই দুইটার ক্ষেত্রে হচ্ছে টেম্পারেচার কন্ট্রোলের ক্ষেত্রে মানে কোন কোন ধরনের হচ্ছে কুলিং বা হিটিং এর জন্য কোন কোন ধরনের, অবশ্যই ভিন্ন ধরনেরই ব্যবহার করা হবে। এবং একটা আছে বললেন যে উপরে পারফোরেটেড থাকে। এখন যদি উপরে পারফোরেটেড থাকে সেই হিসাবে তখন হচ্ছে সেটা বাহিরের তাপমাত্রা সবসময় বৃষ্টিপাত অথবা হচ্ছে হইতে পারে, সেই ক্ষেত্রে হচ্ছে আমি ভিতরের ময়েশ্চারটা কন্ট্রোল করব কিভাবে?
আচ্ছা, আহ, এখানে যেটা মেটাল সাইলোর ক্ষেত্রে যেটা উপরে না, সেটা হচ্ছে হলো নিচে থাকে, নিচে পারফোরেট ফ্লোর থাকে। মানে আহ, ধরেন যে এটা হচ্ছে হলো মেটাল সাইলো, এটা টোটাল মেটাল সাইলো, এইখানে একটা পারফোরেটেড সেকশন আছে, সো এখানে একটা গ্যাপ আছে। তো ওই আমরা যে ফ্যানের কথা বলতেছি, যেহেতু মেটাল সাইলোর হিট অ্যাবজর্পশন বেশি এবং এটা তাড়াতাড়ি গরম হয়, তো সেখানে বাই ডিফল্ট ফ্যান লাগানো থাকে। তো ফ্যান কি করে যে এই যে নিচের যে পারফোরেটেড সেকশনটা, এদিক দিয়ে বাতাস ওই ফাঁকা জায়গা দিয়ে ভিতরে যায়, দেন হচ্ছে হলো এয়ারেশনের মাধ্যমে গ্রেইনের টোটাল কোয়ালিটিটা কন্ট্রোল। এটা হচ্ছে হলো মেটাল সাইলোর ক্ষেত্রে। আর কংক্রিট সাইলোর ক্ষেত্রে আমি এখন পর্যন্ত দেখি নাই ফ্যানের ব্যাপারে, বাট এটা হয়তো আমাকে আরো এক্সপ্লোর করতে হবে যে কংক্রিট সাইলোতে মানে টেম্পারেচার কন্ট্রোলের জন্য আসলে কি ধরনের কাজ করা হয়। ওইটার অ্যান্সারটা আমি এই মুহূর্তে আপনাকে দিতে পারতেছি না, বাট মেটাল সাইলোর ক্ষেত্রে যেটা হয় পারফোরেটেড ফ্লোর অটোমেটিক থাকে নিচেতে, সেটার নিচ দিয়ে হচ্ছে হলো বাতাস যেগুলা সেগুলা পাস করা হয়। এইটা হচ্ছে একটা অ্যান্সার। আরেকটা কি কোয়েশ্চেন ছিল আমি ভুলে গেছি। আহ, আচ্ছা, আপনি কি শুনতে পাচ্ছেন? আর আর কি কোনো কোয়েশ্চেন ছিল? আচ্ছা,
জি, আর একটা কোশ্চেন ছিল হচ্ছে আপনি একটা দেখালেন ইমার্জেন্সি স্টোরেজের ক্ষেত্রে, সেটার ক্ষেত্রে হচ্ছে আমেরিকাতে বাংকার সাইলো মেইনলি ব্যবহার করা হয়েছে এবং ওটা বাংকার সাইলোতে উপরে হচ্ছে বাল্ক স্টোরেজের পর উপরে হচ্ছে তিরপল জাতীয় হচ্ছে জিনিস দিয়ে হচ্ছে ঢেকে দেওয়া হয়। তো
হুম।
এখানে আছে যে মোটামুটি 2-3 মাস স্টোরেজ করা যাইতে পারে, কিন্তু সেই ক্ষেত্রে হচ্ছে এই জায়গায় হচ্ছে আমি যদি সেটা মানে সেই প্রোডাক্টটা যে রাখবো সেটা কি ড্রাইড প্রোডাক্ট রাখতে হবে নাকি ফিল্ড থেকে যে কালেক্ট করবো সেটাই আমি রাখতে পারবো?
না, ওইখানে যেটা মানে নর্মালি ওই যে গ্রেইন এলিভেটর যাদের কথা বলা হচ্ছে, মানে যেই জায়গায় জিনিসগুলো রাখা হয়, তারা তো ফার্মারদের কাছ থেকে গ্রেইন নেয়, মানে কর্ন নেয়। তো তারা যখন কর্ন নেয় তখন ফর এক্সাম্পল তাদের ইচ্ছা হচ্ছে কর্নটা থাকবে 15% ময়েশ্চার কন্টেন্ট। এখন ফার্মার্সরা নর্মালি যেই কর্ন গুলো আনে সেগুলা যেহেতু তাদের প্রাইসের একটা ফ্যাক্টর আছে, ফার্মার্স অবশ্যই চাবে সে বেশি টাকা যাতে পায়। তো দেখা যায় যে এখন 15% ময়েশ্চার কন্টেন্ট বেশি যদি কর্ন সে নিয়ে আসে মানে বিক্রি করতে, তখন সে টাকা কম পাবে। তো ফার্মারও ওরকম মানে ময়েশ্চার কন্টেন্টের কর্নই নিয়ে আসার চেষ্টা করে যেটা 15%-এর কাছাকাছি হবে। সো যদি ওই গ্রেইন এলিভেটরের কর্ন গুলো আসেও, আসার পরে সেটা ড্রাই করার জন্য হয়তো ম্যাক্সিমাম 1% বা 2% ড্রাই করতে হয়। তো মানে যেটা হয় যে যেই কর্ন গুলো আসে সেগুলো অলরেডি অনেক ড্রাইড কর্ন থাকে, এবং যদি ড্রাই না থাকে ফর এক্সাম্পল কোনো কর্ন 16% ময়েশ্চার কন্টেন্ট এবং ওই এলিভেটর দেখা যায় যে 14% ময়েশ্চার কন্টেন্টের কর্নও পাইছে, তখন তারা ওইটাকে ব্লেন্ড করে 16 আর 14 কে মিক্স করে, মিক্স আপ করে এটাকে অপটিমাম একটা মানে তারা ধরে নেয় এটা 15.5%-এ আছে। সেই ক্ষেত্রে ফিল্ড থেকে আসা সরাসরি কর্নটাই আমরা আউটডোর পাইলে রেখে তারপরে হচ্ছে হলো তিরপল দিয়ে ঢেকে রাখা হচ্ছে। তো এইটা হচ্ছে হলো একটা আসপেক্ট। আর যদি অনেক বেশি থাকে মানে কর্নের ময়েশ্চার কন্টেন্টটা যদি অনেক বেশি থাকে সেই ক্ষেত্রে অবশ্যই তাকে আগে ড্রাই করতে হবে, তা না হলে ওইটা 3 মাস 4 মাস 5 মাস ওইখানে সাস্টেনেবল হবে না, টোটালটাই নষ্ট হয়ে যাবে। তো এটা হচ্ছে হলো আউটডোর পাইলের বিষয়। আর কোনো কোয়েশ্চেন থাকলে বলা যেতে পারে।
Is there any other questions? Okay. Thank you everyone for joining this seminar and investing your valuable time. We hope it's the starting of a new journey and we will go really far with your participation. We also hope that we will meet again to execute our next thoughts and plans. Till then, keep your surroundings safe and be safe. Thank you everyone.